amazing. 1 second the wheels aren't moving at all. The next those cycles are handlebar to handlebar. For the rider, timing his shifts and keeping them smooth become all important. It's a clutch situation, literally. Technicians appreciate the essential role that clutches play in motorcycle operation, and they've been passing along some questions about clutches that are particularly interesting to them. Now I've got a chance to answer those questions. By the time I'm through, you should be able to identify clutch operation, bleed hydraulic actuated clutch disengagement systems, service centrifugal clutches, and service pulley drive systems. On a motorcycle, the clutch is essential. It engages and disengages the power from the engine to the transmission, and in turn the power to the rear wheel. It lets the rider have the engine idle without moving, and also makes shifting easier by disengaging the engine from the transmission during gear changes. Now, there are 3 design considerations for clutches. How are you going to disengage the clutch? How are you going to change the drive ratio? Are there any special situations that require other clutch actions? Methods of disengaging a clutch fall into 2 broad categories. Manual clutches, which have their clutch disengagement initiated through the use of a handlebar clutch lever or a foot shift lever, and automatic clutches, which have their clutch disengagement initiated by the engine RPMs. Technicians are most familiar with the designs where the handlebar lever with a cable initiates the clutch disengagement. When you pull the lever toward the handlebar, the cable carries the force from the lever to the clutch push rod and disengages the clutch by allowing the clutch plates and discs to separate. This also interrupts the flow of power from the crankshaft to the transmission. When you release the lever, the springs and pressure plate press the clutch plates together. They rotate as a single unit with power flowing from the clutch basket through plates and discs to the clutch hub and into the transmission. Also, as the discs and plates come closer together, they squeeze out oil between them. The oil serves a double function, cooling the assembly and starting the transfer of power before actual contact is made between the steel plates and the friction discs. For these reasons, it's very important to immerse the plates in clean oil before assembling the clutch. The operation of the hydraulic disengagement system is very similar to the cable type. The hydraulic clutch release mechanism substitutes pistons and a hose for the more familiar cable. Pulling the clutch lever in forces fluid from the master cylinder through the hydraulic line to the slave cylinder, where the piston pushes against the push rod, releasing the diaphragm spring pressure and allowing the clutch plates and discs to separate. Ironically, since the hydraulic clutch is self-adjusting and the performance is so reliable, people tend to ignore it during routine service. As a result, they sometimes experience problems later on. Most hydraulic system problems are disengagement related. Sometimes parts are worn so much that the system can't self-adjust. The fluid is old or contaminated, or there's air in the hydraulic system. I'm doing some routine service work on this VT1100 today. Following this maintenance schedule, I noted that the clutch's hydraulic fluid is due for a change. It shows that the fluid should be checked for the proper level and inspected for contamination or corrosion every 4,000 miles. It should be replaced every 2 years or 12,000 miles, just like brake systems. If I don't follow the schedule, the fluid could deteriorate. Moisture would be absorbed in the brake fluid and cause the aluminum components to oxidize. The aluminum oxide is what causes the fluid to turn brown. Remember, only brake fluid in the system. .4 brake fluid, nothing else. And don't spill the fluid on painted plastic or rubber parts. Cover them for protection. The first step to changing the fluid is to take the master cylinder cover off and set it aside. Next, I'll drain the fluid. Now, to keep air out of the system, I constantly add new fluid into the master cylinder throughout the whole process, so the system never goes dry. I start by putting the box end of a wrench on the bleeder valve and a hose to the mighty vac. I pump up the vacuum, then open the bleeder valve. I maintain the pressure. And this is very important. I keep an eye on the master cylinder. Whenever the level gets low, I close the bleeder valve and top the reservoir off with fresh fluid. I keep repeating this process until I only get new brake fluid coming through the line. I can tell it's new by the lighter color. Remember to keep the master cylinder full. Well, that's it. I'm done changing the fluid. All I have left is to put it all back together and verify that the clutch works. But here are some tips on what to do if you ever have to rebuild the master cylinder. Now, you still bleed it the way I just did, but if the system feels mushy or the clutch does not disengage on the test ride, there might be air bubbles trapped at the high point in the system. This is the most likely spot. Air bubbles just naturally find their way to the highest point in the line. So you want the reservoir to be at the highest point. If you can't do so by turning the wheel or putting the motorcycle up on its center stand, then loosen it with the cover on tight and slide the master cylinder to a higher point. You may have to remove it and hold it up. Pump the handle 5 to 8 times, but not too hard, just an inch or so, just beyond the point where the piston passes the compensating hole, which will release the air bubbles. Then reinstall it and test ride for the final check. On this spare, you can see where air bubbles will escape through the master cylinder's supply port or compensating hole. Here's another tip for getting trapped air bubbles out. Remove the slave cylinder from the engine and push the piston in. I keep an eye on the master cylinder level. Now this can force the air bubble back to the master cylinder or to the high point just before it. And once you get the air to that point, all you have to do is bolt the slave cylinder back on and keep the reservoir high while pumping to get the bubbles out. Besides having hydraulic pressure initiating the disengagement system, the design of the VT1100's clutch serves some special functions. In most clutches, the clutch pack is forced together solely by the pressure of its springs. The VT1100 has a hybrid clutch basket to meet its unique demands, very light lever pull while having adequate clutch strength. In the VT1100, the engine oil pressure and centrifugal forces are used in addition to a very light diaphragm spring. As the clutch lever is released, oil orifices in the basket apply engine oil pressure to the clutch pack. The clutch spring is now responsible for only about 1/3 of the total force on the clutch pack, which results in light lever pull. Engine oil pressure provides another third, and the final third results from centrifugal effects on the engine oil trapped in the clutch itself. There's one more special clutch function that some other Hondas have. It's easy to recognize because you have 2 clutch inner hubs. Inside one hub is a one-way clutch, also called a sprang clutch. When the engine delivers power in normal operation, the 2 hubs are locked together and the clutch operates like most others. However, to prevent the rear tire from losing traction or hopping when downshifting at high RPMs, the clutch must slip a small amount. When the transmission is downshifted at high RPMs, it causes a backloading at the clutch due to the engine's compression braking effect. If the effect is great enough, the one-way clutch disengages the outer portion, which allows the inner portion to slip. This limits engine braking and prevents rear tire lockup, allowing the motorcycle to maintain traction and directional control. To service the one-way clutch, follow the service manual directions. Be sure that it's installed with the right side up. This clutch center should turn one way but not the other. Different models turn different ways because of engine rotation, so check the service manual of the model that you are servicing. I've got the crankcase cover off this TRX 350 to investigate a clutch slipping problem. The TRX 350 doesn't have any cable or hydraulic pressure to disengage the clutch. Instead, it uses this lever, which is controlled by the rider's foot. The lifter is hooked to the shift pedal here at the clutch lever and pushes on the lifter plate. The adjustment screw is seated in the center of this assembly under a rubber plug. This is where we set the amount of free play we're going to allow before the clutch begins to disengage. The adjustment is very similar to adjusting the clutch cable, except you're changing the free play of the shift lever instead of the handlebar lever. The principle is the same. You want it adjusted so that it's not quite pushing before the shift lever is pressed, but so it'll disengage the clutch completely when the shift lever is fully pressed. The service manual recommends that with the cover on, turn the screw counterclockwise until you feel resistance. Then turn it clockwise 1/4 turn. Be sure to tighten the lock nut when you're done. With the cover off, you can see the two clutches. If they're engaged, the power of the engine will transfer straight through to the rear wheel. The clutch assembly on the crankshaft is a centrifugal clutch which has a sprag, or one-way clutch, built into it. The other clutch assembly, here on the main shaft of the transmission, operates from the foot lever. The centrifugal clutch has to come off first. You'll have to remove the stake to loosen the nut, which has a left-hand thread. Now, once it's off, you can see the clutch weight assembly and its drum. This drum shows signs of slipping. You can see the bluing, which by itself might not be bad, but it's suspicious. This inside is definitely damaged. See the glazing and grooving? I have to replace this drum with a new one. Next, I remove the E-clips, washers, and clutch spring to inspect the parts. This centrifugal clutch allows the engine to idle in gear without carrying power to the rear wheel. At low RPMs, the spring tension keeps the weights away from the drum, and the drum doesn't rotate. But as the RPMs increase, centrifugal force overcomes the spring tension. The weights move out, and the shoes gradually force the drum to follow the motion of the inner shaft. At high RPMs, the shoes lock against the drum. This clutch diaphragm spring is designed to keep the weights from knocking just before engagement. The service manual specifies the spring's minimum height. The centrifugal clutch on the TRX might be slipping because of worn linings, grooves worn into the drum interior, or a drum that's dimensionally out of spec. You should check for all these conditions, even after you've already found one reason for slippage. And don't forget, too heavy an oil or the wrong kind of oil can also cause the clutch to slip. So follow the service manual for specs. By the way, if a customer complains that the engagement happens too erratically, the springs may have become weak. Look for damage or wear. Sure enough, not only does the drum have to be replaced, but the weight linings are worn too thin. They measure only 1.5 millimeters. The service limit is 2.0 millimeters. Some current ATVs, such as this TRX, have a one-way clutch nested in the clutch drum. It's a series of hourglass-shaped rollers that allow it to spin clockwise, but not counterclockwise. It has quite a different purpose than the sprag that I showed you earlier that allows the engaged clutch to slip a little. The TRX sprag operates when the clutch is disengaged, as when decelerating. Its operation provides some engine compression braking. Remember, the centrifugal clutch only works when the engine RPMs are high enough to engage the weights against the drum. This one-way clutch provides engine braking when freewheeling downhill with the throttle closed. When a rider decelerates, it's possible for the rear wheel to drive the clutch drum faster than the crankshaft is spinning. Without this one-way clutch, the vehicle would freewheel, leaving the rider with less control. With it, even if the clutch isn't engaged, compression braking slows the vehicle down some. When you remove the one-way clutch to inspect for wear, be sure to reinstall it with the outside mark facing out. If you install the bearing backward, it will engage in the wrong direction. I looked at the automatic clutch. Now I'm going to pull the manual clutch off the main shaft. Oh, by the way, Honda has a brand new tool for holding this and other clutches. Once you have the clutch off, the service manual gives you all the steps and specifications for this clutch. All our discussion on clutches has been about the careful combination of forces: friction, hydraulic pressure, spring tension, and centrifugal force. The drivetrain on this scooter is a good example of the way those forces work together. Now, this CH-80 really feels like it's jumping out of gear, but the trouble is, there aren't any gears to jump out of. There's just a reduction gearbox. There's no shift drum or shift forks or changing gears. Instead, there's a drive pulley in the front and a driven pulley in the rear, linked with a belt. The whole system regulates itself using centrifugal force in the front and a wedging effect in the rear. Before working on the scooter, I disconnected the negative battery cable so the starter motor can't operate. Now, I do this because once the cover is off, the starter gear isn't supported and it could be damaged if it turned accidentally. Now, let's look first at what it is we want the drivetrain to do. Basically, we want the pulleys to change the drive ratios, similar to the change on a 10-speed bicycle. On a bicycle, when we need more torque on the rear wheel, we increase the torque by shifting to the largest diameter gear in the rear and the smallest in the front. How can we produce the same effect with these two pulleys? By making sure that the diameter of the driven pulley is large in the rear and small in the front. Then, just like the bicycle, when we need more speed and less torque, the driven pulley diameter in the rear has to become smaller and the drive pulley larger. The whole system regulates itself using centrifugal force in the front and a spring in the rear. The trick is to control the change. In the front, we use centrifugal force. As the engine speed increases, these rollers in the front pulley are thrown with more and more energy toward the outside of the ring they're in. They quickly acquire enough centrifugal force to wedge themselves up against the ramp plate and force the two halves of the drive pulley together, increasing its effective diameter. This causes the belt to be pulled deeper into the rear pulley, decreasing its effective diameter. Now we need something to reverse the process as the engine slows. We can do that at the rear pulley, the driven pulley, with a carefully selected spring. The spring exerts a constant pressure on the movable face of the rear pulley, a pressure that gradually reasserts itself as less and less force comes through the belt from the front. The spring takes up the belt slack as the front pulley diameter decreases during deceleration. During deceleration, the centrifugal force in the front pulley eases up and the rollers retreat down the ramp face. Now, for this reason, when I took the cover off, the belt should have been riding high in the rear pulley. Now that's the key to the problem with this scooter. Right away when I took the cover off, I could see something wasn't quite right. This belt didn't settle in high on the rear pulley. It looked like something was preventing the pulleys from expanding and contracting in the normal way. Now you might say, so what? You can squeeze the faces apart with your hands, but they won't necessarily spring back because of the roller pins and seals. Well, they might not when the scooter is at rest, but they always should when the scooter comes to rest while idling. I went looking for the reason, or reasons. I took the pulleys apart and looked for belt wear and checked the width against the service manual specs. Then I looked for any pulley wear, such as flat shoulders on the four pulley faces. It's not common, but if the scooter is operated at the same speed all the time, the belt doesn't ride up and down on the pulleys. It sits at one level, and it can actually wear a groove. Now, these pulley faces didn't look too bad. Since belt friction is so important, I checked right away for oil contaminating the pulley faces, but I didn't find any. And the belt wasn't glazed either, which is another possibility. When I got to the driven pulley, I wanted to look at the shaft, so I set the assembly in the clutch spring compressor and took off the lock nut that held the pieces together. I checked the spring, it looked all right. Now I'd worked my way down to the section that interested me the most. I twisted off the seal collar and inspected the guide rollers, pins, and the shaft. Sure enough, the shaft was dry and scored. This part will have to be replaced. When I install the new part with new seals, I'll have to be sure that the shaft is greased, the way it shows in the service manual. Now keep in mind, anything like this that interferes with the balance of forces in the drivetrain is a telltale sign of trouble. A glazed belt, binding, oil, or unusual wear on the pulley faces. We have one more feature here that's worth mentioning. To make the system completely automatic, there's a centrifugal clutch on the same shaft as the driven pulley, so that the engine can idle without passing power to the rear wheel. Remember, the centrifugal action on the front pulley never disengages the powertrain. That's why we need this centrifugal clutch back here. We hope this program has answered your questions about clutch operation and service. Proper clutch operation is vital for a ride that's safe, fun, and wins.